video, we will going to focus on the mathematical language and symbols, the language of sets. But before that, let's just first define what is the meaning of sets. Mathematically speaking, sets are considered as an organized collection of distinct objects. So let's deal with this example. Set A has an element of 1, 2, 3, 4, and 5. Sets is usually represented by a capital letters. The objects of a set are separated by commas. The individual objects in a set are called the member or the elements of the set. It can be represented by listing its element between braces. And this kind of example is a well-defined, which is specifically listed. We have here some given notations for sets, and they are, first, the elements 1, 2, 3 is equals to set of integers greater than 0 and less than 4, or x is to x is an integer, and the x is less than 0 but greater than 4. We also have the empty set denoted by empty braces, or the sign for no elements. We can have infinite set, for example, element 1, 2, 3, so on and so forth, or so what do we call the ellipses, meaning that the set has an infinite number of elements. We have a symbol showing membership. We relate a member and a set using the symbol E. If an object X is an element of set A, we write X as an element of A. If an object Z is not an element of set A, we rewrite Z as not an element of A. E denotes as an element of, or is a member of, or belongs to. E with a diagonally line denotes as is not an element of, or is not a member of, or does not belong to. Example, if set A has an element of 1, 3, and 5, then we can come up with a conclusion that 1 is an element of A and 2 is not an element of A. Let's now move on to the first set representation, the set rooster notation. A rooster is a list of the elements in a set. They are surrounded by braces and separated by commas. So let's deal with this example. The set of natural numbers less than 5. Natural numbers is equals to 1, 2, 3, 4, 5, 6, 7, 8, and so on and so forth. Natural numbers less than 5 is equals to 1, 2, 3, and 4. Therefore, the set N has an element of 1, 2, 3, and 4. And we have here some important symbols and signs that is useful and we must be considered while dealing with this language of sets. So let's discuss them one by one. N, that stands for the set of natural numbers. W, that stands for the set of whole numbers. Z, that stands for the set of integers. Q, the set of irrational numbers, terminating or repeating decimals. Q prime, the set of irrational numbers, non-terminating or non-repeating decimals, or the set of real numbers, and C, the set of complex numbers. Now, let's move on to our second set representation, the set builder notation. Set builder notation is a mathematical shorthand for accurately stating a specific group of members. So that means that it has something to deal with the sign and symbols that I've already mentioned. So example, write the following sets in set builder form. Set A has an element of 2, 4, 6, and 8. Solution. 2 is equals to 2 times 1, 4 is equals to 2 times 2, 6 is equals to 2 times 3, and 8 is equals to 2 times 4. So, the set builder form is set A has an element of x is to x is equals to 2n, in which n is an element of n, and n is less than or equal to 1, but greater than or equal to 4. And also, Venn diagrams are the simplest and the best way for visualizing representation of sets. For now, let's find the difference between finite set and infinite set. First, finite set. A set which consists of a definite or a countable number of elements. For example, a set of natural numbers up to 10. Set A has an element of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We can see to it that we can still count it. While an infinite set, a set which is not finite, is called an infinite set, or we cannot afford to count it. Example, a set of all natural numbers. And now, let's move on to the difference between equivalent set and equal sets. Equivalent set, if the number of elements is the same for two different sets, then they are called equivalent sets. The order of set does not matter here. It is represented as n has an element of A is equals to an element of B, where A and B are two different sets with the same number of elements. Example, if A is equals to 1, 2, 3, and 4, and set B is equals to red, blue, green, and black, in set A there are 4 elements, and in set B also there are 4 elements. So therefore, set A and B are equivalent. While in equal sets, the two sets A and B are said to be equal if they have exactly the same elements. The order of elements do not matter. Example, set A has an element of 1, 2, 3, and 4, while set B has an element of 4, 3, 2, and 1. And last and definitely not the least, the difference between joint set and the disjoint set. Joint set, two sets with common elements. So it means that it would have an intersection when we were going to plot it in a Cartesian plane. Let's do with this example. Set A has an element of x, y, and z, while set B has an element of e, y, and s. If we were going to take a look of it, the same or the common elements that they have is the y. So it means that the point of intersection is at point y. While in this joint set, two sets without common elements naman. Example, the set L has an element of 1, 2, 3, and 4, while the set M has an element of A, B, and C. Thank you. I hope you learned something from me, and I know that I will learn a lot of things from you. Have a blast.